Let's go through this example problem. We're going to go ahead and work from absolutely nothing all the way up to having a three-dimensional structure of the nitrate ion. Now for that, of course, we're going to follow these rules. We're going to draw our Lewis structure first, then count our groups, set up our geometries, and then draw and have any deviations that are necessary. Now, I'm going to go ahead and have you pause and do the drawing in a moment. What I will do is after each of these major steps, I'm going to give a little bit of a hesitation in my dialogue so that you can pause the video quickly. So if you find you made a mistake, you can just go ahead and work backward, correct it, and then continue going forward. Or if you find that you're stuck, you can work up into a certain point, pause, and then continue going from there. So with all that said, go ahead and pause now and start in with this structure. Okay, so for the nitrate ion, the first thing we have to do is actually think through what our central atom is going to be. And we know it's going to be nitrogen because it's less electronegative than oxygen. So we're going to have nitrogen in the center, oxygen, oxygen, and oxygen. We'll be ready to start drawing in bonds in a moment, but first we want to count up our electrons. So nitrogen brings 5 valence electrons, oxygen brings 6. I have 1 nitrogen atom, I have 3 oxygens. That gives me 18 electrons from oxygen, gives me 5 electrons from nitrogen, and I have an extra electron from that negative charge. So if I add this up, it's 19, a total of 24 electrons to work with. So we go ahead and start drawing them in. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I've used up all of my electrons. I check my octets. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6. I can see right away that I'm going to have to kick in one of these electron pairs and make a double bond. 2, 4, 6, 8, 2, 4, 6, 8. So this stays at its octet, this gained up to the octet, and that's why I'm always harping on us to make sure that we do our filling on the outside first, then shift inward if needed in order to make the double bonds to give the central atom the octet. Now, of course, we could have also done it for any of these other ones, so we know that we're going to have 3 different resonance structures for this, but we're going to work with just one of those resonance structures. So we'll have N, O, O, O. I'm just redrawing it a little bit nicer. There we are. Now, you can kind of see what I've done here. I've just already kind of sketched it out so that I have these bonds somewhat optimized for their geometries. I'm still in flatland. I still haven't gone on to the next step. All that I'm doing is saying, well, I've got 3 major bonding regions. Let's space them out a little bit around the central atom. So now if you needed to pause, go ahead and do so. Okay, so let's count up those electron groups. I have 1 group here. I have 1 group there. Remember, the double bond only counts as a single electron group. And I've got 1 more there. I have a total of 3 regions of space that have electrons in them around the nitrogen, which means that it's going to be in the AX3 family of geometries. Let's be more specific and actually assign those. I have A. I'll have my X, 1, 2, 3, AX3. I have no free electron pairs, so it'll be an AX3 geometry. And of course, for simplicity, we just omit the E0. We don't need to communicate that there's no free electron pairs. We just write AX3 as the actual geometry. Now that's going to be our electron group geometry and our molecular geometry. Okay, so now our next step is to actually draw and then deviate this as needed. So if you needed to pause, go ahead and do that now. Okay, if not, we have 3 in our AX3 geometry. We know that that's going to start out being a trigonal planar geometry. And we know the trigonal planar geometries start out being 120 degrees apart for all three of the bonds. So we can go ahead and have our double bonded oxygen here at the top. I know that's a different orientation that I had over there, but that's not a big deal. And again, I'm not going to worry about drawing the periphery electrons on anymore because all I'm concerned with is my central atom. Now, I need to do any deviations that I have. My double bond will take up a little bit of extra space, which is going to squish this area just a little bit. So we can expect that this will be a little bit bigger than 120 degrees right here. This will also be greater than 120. And we're expecting this is going to be less than 120 degrees. So less than 120 degrees in this section, greater than over in these.